I'm Zain Fathoni. I'm Zain Fathoni on Twitter and GitHub and almost everything else. Today I'm going to talk about state machines meet React hooks. Who knows state machines here? All right, so yeah, I know that you're a bit oldies because state machines are old things, right? It has been around for decades, and now we are bringing this old stuff into React hooks, which is just probably a few months ago released on the stable version of React. So, yeah, I have a family, I have 2 kids, and I'm living in Singapore, working as working at NinjaVan as a front-end stuff. Previously, I was a back-end developer, but I just moved to front-end for 1.5 years. And I love React and its hooks. Who loves hooks here? Oh, great. Okay, what this talk is. Here I'm going to give you a very brief introduction to state machines. So for you who just born yesterday, who never heard of state machines, probably you need to get some few basic concepts of it. And then I'm going to walk you through to my personal journey when I was working on a feature in NinjaVan. But that journey is too long to cram up in 30 minutes, right? That's why I cut it down and I simplify those things. So what you're seeing here is not the real thing that I built, but it's just a simulation of my journey at the time. So, and since it's a code journey, so there will be a lot of code. So luckily, this is the first talk in the morning, so I hope you are fresh enough to digest more code this morning. And what this talk is not is, this is not an introduction to React hooks, so I'm not going to introduce you to any concept of React hooks. And it's not also a deep down to the state machines concept, because it has a lot of concepts. If you talk about it thoroughly, it will take a few days probably. So, what is state machines? Well, when I'm mentioning state machines, I'm referring to these finite state machines, which is on Wikipedia. Yeah, it's like this is the definition, and we have some states and the stuff. So, yeah. Oops. And why are we bringing this old stuff into front-end stuff? Because usually state machines are only used in critical systems, in oil and gas company, in NASA for building the rover to send to Mars, because they can afford to have an error or a bug in production, not like us. We can afford it, right? We can afford a bug in production, and we can immediately push some code and deploy it. But that's not the case for them. They cannot just push a code to Mars, right? Because it takes months to get there. So, but why bringing this complicated stuff into front end? There are a lot of explanations, which is explained by the creator of XState in this talk. So you can just go through the documentation and take a look at why does this important. But one of the idea that I'm getting sold out is because it provides a common language for designers and developers. So let me explain it to you. Anybody ever get this kind of flow from designers? Or, yep, 1, 2, 3. Okay, so are we the only ones doing the complex stuff? So I have a page in our product in NinjaVan, which is basically a calendar. So this calendar, an interaction in a calendar is a lot, right? There could be creating new stuff, or viewing the stuff, or viewing the list of items in calendar. And since we are a startup, we do it lean. So instead of having all requirements given up at the first place, we just get the requirements gradually, one by one. So initially, I got only probably one of this diagram, but then on the next sprint, I get another one. On the next sprint, I get another one, and this diagram getting more and more complex. And it's getting harder for me to understand my code and relate my code to this diagram. But luckily, I'm getting pitched by this idea. So somebody, when I watched the talk, he said that state machine provide a common language for designers and developers. And I thought it quite makes sense, because by having this, by using state machines, we can actually code in a way that the diagram is presented to us. And I will show you later that we can do vice versa. So my problem at the time was the complex UI flows that I get, it requires multiple states. By states here, I mean states in React. So it can be in hooks or it can be in class components, but it's basically the React states. And multiple states are generally too implicit, which means probably let's say we have 3 states. We have a combination of 3 states on that component, right? And then we have 4 states, we have combination of 4 states. And imagine if the UI is too complex, we can get the states exploded, and it's getting harder to manage the states inside that component. Yep. So those implicit states, for me, it's harder to reason about. That's why bugs keep showing up on production due to these invisible states. So I thought that I covered all the states, but apparently there's some other combination of states that is not covered yet and is appearing in production. So yeah, let's try using state machines to solve this problem. So my hypothesis is by using state machines, we can make all states visible, which means if we have no invisible states, means no hidden bugs anymore, right? So let's hope it turns out that way. Enough talk. So I told you that there will be a lot of code. We are starting to jump into the code. I will give you a brief state machine introduction through the XState API. So this is a simple toggle machine example. So I'm just importing a machine function from XState, and I pass down a configuration object to the machine. This configuration object should contain at least, first is the initial state, so which state that it's initially on when it started, and then all the available states. So in this case, I have inactive state, and then I have active state as well. And within those states, we can define state transitions, so which is a way to move between states. So in this case, on toggle events, we move to active state, and from the active state on toggle events to the same event, we move to inactive state. Yeah, so this is the bare minimum of a state machine. So we can try to copy this line, and we can visualize it from the code. Yep, here it is. So now we got our code visualized like this. So it looks like the diagram that I've shown you before, the diagram that we got from the designers. It seems a bit overkill, right? I mean, toggle stuff, what can be more complex than this? Why do we need this ceremony just for toggling stuff? But we will get to it soon. So let's start the journey. Here, I'm gonna walk you through my journey, and I'm gonna split them step by step. So each step consists of, first, the conventional implementation of it using hooks, and then next we will go into the state machine definition, and then next we will integrate that state machine into our app. So for the first, let's say, imagine this is, we are doing it in sprints, and this is our first sprint. So the first feature is simple. It's just toggle the model visibility, which, let's say I have button, and I click, and the model shows up, and I close, and it closes. It's as simple as that. This is our bare component, which uses a button and a model. And I feel nothing here yet. So for tracking that visibility state, usually we use state. And then we just initiate the state with false. And on button click, we set it to true. On close model click, we set it to false. So this is our implementation. It seems simple, right? Why do we need state machines? But let's try doing this simple thing using state machines. So I just add an ID here, so that it's easier for us to understand that this is a machine for this case. So we have an invisible state as an initial, and then we put an open event so that it can go to visible state, and this visible state has a close event to invisible state. So this is our simple machine, which looks like our toggle machine before. And when we visualize it, it has similar thing. The only difference is that we have different events to trigger. So by having different events, there is no way for this state to, let's say we're in invisible state and we send a close event. It will do nothing because there's no close event on this state. So that's what makes it contained. We cannot go to any other state which is not defined here. So let's integrate that state machine into our app. This is the same barebone app, but I just imported another stuff. Use machine here is React hooks, React custom hooks, which is written in X-state. And you can look at the explanation on the documentation. I won't walk you through. And these custom hooks accept first the machine itself, the machine definition that we just did, and then it accepts some options, which is one of them is the DevTools, which means that we can debug our app or our state machine in Redux DevTools. And we get the current state and the send event, send a function to send the event. So for opening the model, just simply send an open event. And for closing the model, just simply send the close event. And here, to determine that whether the model is shown or not, instead of passing visible state before, we pass down the current state and the value of the current state. And if the state is visible, then we display the model. Yep, this is it. And we still have the same working model component. But the difference is we can track it down in Redux. So we have an open event here, changing state visible to invisible to visible. And we have close event here, changing state from visible to invisible. Okay, that seems simple, but now let's go to the sprint 2, requirement 2, which is we have to differentiate between view and edit screens. Back then our model was just no content, right? But now it has a content and it has a edit button. So it is viewing the thing here, and then when you click the edit, it is editing that thing and it can submit. So that's the second requirement. This is our old code in conventional hooks. We have to add another state because we are checking another thing right here. So we just add an editing state and then derive the state value that we are passing down to the model. So we are passing down this view and edit state value based on those two states before. So the visible and the editing. If it is visible, then it's not editing, then it's view. And yeah, something like this. And that's for getting the state. And now for changing the state, we should propagate the events of clicking or of clicking those buttons to setting the states. So right here we set editing to false when we want to when we are closing the model, so it gets to the initial state, and then on edit button we just set it to true. So that's our implementation. It's still manageable so far. So why we bother writing state machines? But we do some unuseful stuff sometimes, right? So now let's write state machines. And right here, I'm going to introduce you to a new concept called hierarchical state. So here we have a new state, but it's not sibling of the existing state, but it has to be children of an existing state, because this state is actually inside the visible, because this state is only exists when the model is visible, right? And we can just add those states inside it. So this is called hierarchical state. And inside the visible state, we have a view state, which is an initial state. And then we can go to the edit state. But then from edit state, we need to go to the parent state, right? So there is no, the default way when it accesses the state, it can only access its sibling state. So how do we access the parent state? Luckily, XState provides a way to do it by defining an ID on a parent state or any state or anywhere on the machine. And then we can just refer to that ID by putting a hash in front of it. So this is our state machine definition. Then it looks like this when we visualize it. So on invisible, this invisible and visible thing is the same thing that we have previously. But then we have two new states inside the visible state. So when we are on view, we can edit it. And when we are on edit, we can submit it. And when we are inside any of these, we can still close the model. That's how it works, right? So let's implement this in our state machine. This is our previous one. We need to change the value that we are passing to the model because now our visible state is not string. It's not always a string, because on visible we have two inner states, so it will be an object. So we are passing down that object. So if the state is an object and contains visible, and visible contains inner state, then we pass that inner state. Otherwise, it will be undefined. So that's why this is still valid for our model. So model will only show when we have some inner state in the visible state. And then for edit and submit events, it's just simply sending those events out using the send function. That's it. And when we try doing this, yeah, it works. And we can also see the redux here. So now when we are opening the state, yeah, now we have this visible edit. So when we are close, the value is invisible, and when you open it, the value is now visible.view, and now it's visible.edit. So it's how XState represents the states. Okay, so far we are getting a bit more complicated here now. So on the sprint tree, we had a new feature to show the create screen when opening model with empty data. Remember that my case was a calendar. When we click a date, there could be something in it, which is this case. But there could be nothing on it, which we don't have anything to show, right? So that's why we have to go immediately to the editing mode, which is called create, because we are creating something there. So we have two cases now. And to accommodate that in our conventional implementation, we add another state called data, the data of that thing in the calendar, and we initialize it with an empty array. So now it's getting more complicated. Well, we have to incorporate these three states, visible, editing, and data, and derive a state value from that. Then we have to write these conditional stuffs. This seems a bit still more manageable, but we are still far way forwards. So just update the buttons to have two things now. Now we can open empty, which is the old stuff, and then we can open axis, which is we are opening the model and we are setting the data to have some content. Here is just an empty string to simplify. And don't forget to clean up the data when we are closing the model or submitting. So that's our implementation. Okay, now it's getting more complex because now all those additional logic are scattered everywhere, and it's harder to understand because it's too implicit. Which state this leads to, and which state that action leads to. So let's try implementing this with set machines. And here is where it feels more useful now. So in this case, we're triggering the same event, which is opening the model. So we need to transition the state from invisible to visible. And here is how we define the transition, but there is another way of defining this transition, which is defining it as an object so that we can add some more things here. So this is actually the same thing with the previous one. And there's another way to define it as an array so that we can target different things. So now we can target different states from the same state within using the same event. How do we differ between this target and this target? We differ it using condition. So this condition in state machine is called guard, which means like imagine a state is a place and we have guards in front of the state, in front of the place, like our guard, which is scanning our tag. So if somebody is trying to come into this stage without having the proper tag, they won't be allowed to come in, right? So this is why it's called guard. So here we are guarding that if the data is 0, if the data length is 0, and then we go to this state. Otherwise, we go to the previous one. So just add a create state, and that's it. So this is our new visualized state machine. We have a new condition here. So it's the same event, but different condition. With this condition, we go directly to create. And the rest are the same. So when we implement this into the machine, let's rename the current button. And then, so now it's open empty and pass down an object. Instead of just passing out a string, now we pass an object with the type of that string and a payload in it. So we pass down an empty payload. And we also need to have another button which sends the same event but with different data here. That's it. That's our implementation in our component. So it still works the same. Yeah, I did open empty, it goes to create immediately. Okay. Now we get to the final sprint in this talk. We have to show list screen when we are opening a model with multiple data. So imagine that there is a date where we have multiple things there. So we don't know yet which one to view, right? Which one to view like this. So if we have multiple data, which one to show? We don't know. That's why we are displaying a list of them, and the user can click on one of the lists and we can show the view. And it does the same thing like before. So now this is our old component. Add another state, which is called index, which represents the index that we are seeing. And I initialize with -1, so if we use now, when we compare it to other numbers, it's a bit strange in JavaScript, right? So just let's use this sentinel value. Then we incorporate that index into our new state, which is list. And don't forget to add another condition, because now this condition is changed because of this. Add new buttons with different data here. Don't forget to reset that index to -1 when you close the model. So now it's getting more and more complicated. Well, this is not mind-blowing yet, because it's still step 4. Imagine that in production I have like step 10 or step 20. So yes, it blew my mind. So in state machines, we can do it the old way. We can do it the same way that we did before. So just add another guard and another state to go. But then now it's getting harder to read, right? Because then what's the point of using state machine if we still get it hard to read? We can alias this state. We can alias this guard into a simple string, so it's more readable. So now we have if empty, then this; if single, then this; if and else, this. And we define those guards into this object instead. So this is the second object that we pass to the machine. And it's just naming the condition as a string. And then define another list state with any actions interacting with it. So here is our new state. We have a new open event state with different condition, but now it's with a proper name. So if it's empty, then it's going here. If it's single, then it's going here. If it's nothing, then it's going to the state which is initialized to this. So yeah, now just add another button with open event. The same open event, but with different data. Now we have multiple data. And inside the model, we have an interaction to view the details and go back to the list view. So we just pass down the back and view events. And that's it. Our implementation is now more readable, and it's easier to digest. And now we can inspect this. Yeah, it's working so far. All right. So let's compare our previous implementation, the old ways, to the state machine implementation. So without state machines, we usually use state, right? But then with use machine, we don't use state anymore. We just use machine. And replace those multiple states before with just a single call out of the use machine. And we have those two things here now. This is the state and this is the event. And now instead of having those implicit set state calls, which we don't really have any idea what does this do. Oh, this is doing the same thing actually, but yeah, it's harder to understand. We need to read this code probably 2 or 3 more times to actually understand what's happening on this code. But by using state machines, we can just know what's happening on this button or what's happening on this action just by looking at once. And now our app is more simple and easier to understand. But we're actually just moving away the complexity from that to the state machine, right? But the state machine is still complex, right? Yes, it's still complex, but the difference between that state machine, the complexity of that state machine and the complexity of the previous implementation is this state machine can be visualized easily. So by using the same visualizer, we can visualize all the states in a way that corresponds to the flow that we get from the designers. So this visualization, for me, it reduces the cognitive overload. So based on my experience, the advantages is now, since all states are visible, it's easier to test. So we can just test from whichever state to go to whichever state. And in fact, I did all the tests. So I am confident enough with my machine. I am confident that my machine won't break. But is it bug-free as I hypothesized? Apparently not. So it's not completely bug-free. So the bug comes not from the state, but it came from the discrepancies between the state and the rendered views. So I had the correct state, but inside that model, so far we're just passing down the state to the model, right? But what's happening inside the model is it can go wrong over there. So the bug is coming from that model view. So instead of just testing the state, we should also have tested the rendered views as well. In this case, we should have tested the model view. So that's why I'm suggesting us to consider integration tests. So my lessons learned in this journey is when we are using state machines, it must be designed thoroughly because it's a complex stuff. So the state machines will just work, but it works as we design. So if we design it badly, then it will go bad. And yes, it's easy to test the states because just testing the string, testing the object, right? But don't forget to test the rendered views. And another thing that I learned is there's no silver bullet. We cannot use state machines everywhere. Just like we cannot use Redux everywhere, and we cannot use get derived state from props anywhere. Yeah. So just be mindful that we might not need state machines as well. So my takeaways from this experience is please use state machines sparingly. So use it when you need it. And when you use it, isolate the state management into custom hooks so it's easier to understand and to test. And always test your code thoroughly, which means testing all the codes, including the view. So in this talk, I barely scratched the surface of state machines concepts. There are a lot of things more in state machines. You can just read up to the exit documentation. There are a lot of things there. Even, in fact, I also didn't learn all the stuff there yet. So I just explained what I implemented. So I'm also suggesting you to learn to read Testing Trophy by Ken Sidots. I actually took his course, and it seems much more useful to prevent some bugs happening in our code. Now, so we can get enough confidence within our code. So I think that's all. Thank you for your attention. And I want to give a special thanks to David Corshit, which is the creator of XState, and Rodrigo Pombo for his amazing code server that I used here, even though it is still in alpha version, but it's pretty good, right? Nothing wrong happens. So you can access this slide in this link, and that's all. Thank you.